Today is the last day of the circles unit. So as you can see, we have many circles to think about over this unit. The test is tomorrow, Thursday. Today is Wednesday. So we're going to knock out that review. And when it comes to the test, I just got one question for you. Are you red E? Let's do this. Alright, secant line. So we want to give the examples in notation format. So a secant is a line that goes through a circle. So we can pick this one right here that goes through it with arrowheads. Okay, line AD. Okay, a central angle. Well, it has to be an angle from the center. So something like this. And there's more than one answer on these, but I'm just giving you one of them. AOB, angle AOB. Okay, a major arc has to be more than halfway. So from A to B, past C, all the way to F. Okay, so that would be A, B, F with an arc on top. A minor arc would be less than half, so like from A straight to F, AF, and remember, it's got to be two letters to be a minor arc. Okay? And a chord, we'll go orangish. Well, it's not going to work. Go with this tealish color. Alright, check it out. From A to D, stopping at those endpoints, AD, that would be a chord. So notice how on top, that's a segment. Okay? Alright, point of tangency. So I got a tangent line over here, and at letter B, that would be a point of tangency where it touches it once. So I'm just going to put the letter B is a point of tangency. So that means the tangent line is going through that point of tangency. That would be line BE. Line BE. Okay, a diameter. Well, that would be from one side straight through the middle. AC, and it is a segment, like a chord. But a radius is only halfway. It's from O to C, that's one example. So again, it's segment OC. And then center, we have one central point. And that would be O, point O. Alright? So all that stuff is on your first day notes for circles, all those vocab words. So, alright, let's knock these out. So these are tangent lines that intersect at a point. This was from our first assignment. We know those are going to be congruent. It was also on our quiz. So if they're congruent, we set these measurements equal. So 14y minus 4 equal sign 8y plus 11. I have y on both sides, and it cannot be on both sides. So I'm going to get rid of the smaller y, which is 8y. It's positive, so I'm going to subtract. So minus 8y, minus 8y. 14 minus 8 is 6y. Bring down. Minus 4 equal sign 11. And now it's a two-step problem. I get rid of my loner, the minus 4, by adding 4. Okay, 11 plus 4 is 15. Divide by 6. Okay, and we get 5 over 2, or 2.5. Okay, same thing over here for number 2. Again, these are congruent. So 5z minus 12 equals sign 113. This is already a two-step problem. We do the opposite of the loner. We add 12. We get 125. And then to get rid of the 5 in front of z, we divide. And that's 25. 2.5 for 1, 25 for 2. Okay, this should remind us of a quiz we took, and that first assignment still. If we know that the radius below is 5, then I'm going to replace r with 5 and 5. And I need to think, what's this whole length? If that's 5, and that's 8. 5 plus 8 is 13. So if I redraw this, 5, 13, and b, then I use the Pythagorean Theorem. 5 squared plus b squared equals 13 squared. I do some math real quick. 25 plus b squared equals 169. Minus 25, the loner on the left side. Okay, and square root to get rid of the square. b equals 12. Okay. Pythagorean Theorem. Make sure this right here, this 13, that's where most people mess up and just put 8. It's not just this 8, you have to add the 5. Alright, find the measures of the following arcs. Before we do that, we need to figure out the central angles, because that'll help us find the intercepted arcs. So, do you remember what these types of angles are called across from each other? They're called vertical angles, and they are congruent. So, if angle DCE is 60, then angle ACF is also 60 degrees. Okay? And then I want you to think about over here, if this is a straight line, right, and over here this is 60, then I have a linear pair that are supplementary for this angle FCE. So I think of doing 180 minus 60, and I get 120. I'm going to fill that in for FCE right here. Okay. Now, right here, I know this means 90. And I also know still that this is a straight line of 180. So if I want to figure out this missing angle, I'm going to take the two I know, 60 and 90, add them up, and subtract from the straight line 180. So 60 plus 90 is 150. And then 180 minus 150 gives me 30. So I'm going to fill in BCA right here with 30 degrees. Okay. Cool. Now let's do this. Number 1, the measure of angle A. Sorry, A, the measure of angle DE. So I'm going to look at DE. From D to E is 6D in the central angle. That's it. Okay, BFD, major arc. From B straight to F and then to D. Okay, so that means I'm adding up 1, 2, 3, 4 different angles. Okay, so B to F, D, I'm adding 30 plus 60 plus 120 plus 60. So 30 and 60 is 90, plus 120 and 60 is 180. I get 270 degrees. Okay, BF, from B to F, I'm adding two angles, 30 plus 60, 90 degrees. AB, there it is, and the center is 30 degrees. DEF, starting at D, going to E, going to F, two angles that make half a circle. I know it's 180 degrees. BEA, this is a major arc because I'm going from B to E and then all the way to A. Okay, so I'm adding 90 plus 60 plus 120 plus 60. Okay, add all that up and I get 330 degrees. Then EF, okay, from E 2f is 120 on the central angle. Alright, so again, if you find the central angles, you'll be able to get the intercepted arc lengths, the measurements. Alright, let's remember these. These are not that hard because these angles are inscribed. They are on the edge, right? So this angle C is on the edge, like the vertex is on the edge. So we know that that inscribed angle is half, exactly half of this intercepted arc. Okay, so I'm going to put angle, C, equal sign, 1/2, and then the intercepted arc is 56. Alright, so C equals half of 56. And what is half of 56? 28 degrees. Okay? So where would I have found that on my circle formula chart? So let's take a look. If I can get this to move, that'd be sweet. Okay, so here's our formula chart that we're going to be using. Okay, so the one we just did, let me just put this on a smart notebook. Cool. So, what we just did, and you're going to have literally this sheet on your test, is right here, okay? The angle equals half the arc, okay? And it says it right here, angle equals half the arc. So if you see the vertex on the edge, look for that on the formula chart, okay? Alright, over here, now don't get confused on this because what if they don't give you the intercepted arc? What if they give you the angle? Okay, so you write it the same way. Angle, which is 40, equals half the arc, which is x. So instead of just finding half of the arc, okay, we're actually going to be doubling the angle because to get rid of this 1/2, I need to do times 2, cancel, cancel, times 2. 40 times 2 is 80, and what do you know? That works out. Alright. Okay, 7 and 8. So this time I see an angle on the inside with 2 intercepted arcs. Okay? So what I'm going to do is I'm going to go back to that formula chart and look for that. Where do I see some? Oh, I see something like that up here. I see an inside angle, right? Angle 1 right here. And that's supposed to be equal to half arc plus arc. And that's what these two things are saying right here. Alright? So, since that's the case, and we did that on one of our assignments, we should be able to do this. It's going to be good. So, let's do it. First thing I'm going to write is the angle, which is x. I'm going to put an equal sign, then a half, parentheses, and then arc plus arc. 131 plus 52. What is 131 plus 52? 183. Then I needed to find half of 183. You would probably get a fraction, but make sure you hit Control Enter, and you get 91.5. What about over here? Again, same idea. Angle equals half parentheses arc plus arc. 93 plus 76. What is 93 plus 76? Okay, so we get 1/2 of 169. And what is half of 169? Plug it in your calculator, you get 84.5. Okay. Remember, these problems are on your review for a reason, so you want to make sure you know how to find it on your formula chart and what to do. So, on number 9, where is this angle? Well, this angle looks to be on the outside. So let's take a peek at that formula chart. Oh, look at that. Because it says outside angle. Okay, well, that's supposed to be equal sign half, big arc minus small arc. That's what each of these is saying down here. Whether it's tangent secant, 2 tangents, 2 secants, as long as the angle is outside, this is our rule. Half of big arc minus small arc. So, let's do it. So the angle is x equals 1/2 parentheses big arc minus small arc. 143 minus 68. What is 143 minus 68? So we should get 75. So what is 1/2 of 75? That's the question. And we should get 37.5 degrees. What about one like this? Again, if you have 2 tangents that touch at one point, you know the full circle is 360. So if the full circle is 360, I'm going to do 360 minus 242. Okay, and I get 118. That is not the final answer. Okay, 118 goes right here, and now we get to use that the way we did on number 9. Okay, so my missing angle over here, okay, this is what's missing. We'll call it x. Why not? So x equals 1/2 parentheses big arc minus small arc. 242 minus 118. What is 242 minus 118? Okay, so I get mental math here. 82 plus 42 is 124. So x equals 1/2 124. And then what's half of 124? But 62 degrees. All right. Cool. Now, on 11 and 12, this is where it's a little different. It's the same formula, but we're going to end up with a different, it's going to look a little different in the process. So let's do this. Same format. Outside angle, 43, equal sign, 1/2, parentheses, big arc minus small arc. 121 minus sine x. This time our x is not on the left side by itself, it's inside the parentheses on the right side. So we need to get rid of the half. Okay? So to get rid of this half, times 2, cancel, cancel, times 2. 43 times 2 is 86, equals 121 minus sine x. How do I get rid, x is on the right side, how do I get rid of the 121 that's positive? I subtract 121. Alright, and when I do that, I get 35, negative 35, equal sign and that's negative x. Alright, now this is weird because I have a negative on both sides. I need a positive x. If you remember when we did this on the notes, if you got a negative on both sides, those negatives cancel out because we're going to divide by negative 1 on both sides. But basically, positive x equals positive 35. That's our answer. Okay. 12, same idea. Angle 25 equals 1/2 big arc minus small arc. So this time it's 132, okay, minus x. This one's going to look a lot like the last one we did. To get rid of the half, we do times 2 times 2. 50 equals 132 minus x, minus 132 minus 132. That gives us negative 82 equals negative x. X is equal to 82 degrees. Okay. Alright. These are fun. We remember these from our last assignment of the unit. Woo -woo. So where would we find that on our formula chart? I already see it. If I have intersecting chords on the inside, I do A times B, so like this times this equals C times D. This times this. Like we did on our last assignment. Check those notes. So let's do this. Okay, so x times 10 on the same chord, right? X times 10 equals, and then 12 times 15 on the other chord. Okay, x times 10, 10x. 12 times 15 is 150, I believe. Nope. 180. 180. Don't want to steer you wrong. Alright, and then to get rid of that 10, we divide by 10, divide by 10, x equals 18. It's not degrees, it's just 18. Same thing over here, x times 6, which is 6x, equals 4 times 9. 6x equals 36. Divide by 6. X equals 6. Alright. Alright, over here, getting closer to the end. We're going to do this a little bit faster. So on this one, I look at my formula chart, and that's where I have two secants. And remember, it's outside times the whole thing equals outside times the whole thing. Let's do that. So what's on the outside here? 10. Times, what's the whole thing? X plus 10. Equals, what's on the outside? 9 times, it's not 21. What's the whole thing? 21 plus 9 is 30. 9 times 30. Okay? You gotta think of the whole thing. So, 10 times x is 10x. 10 times 10 is 100. And then 9 times 30 is 270. Get rid of the loner. 10x equals 170. Divide by 10 equals 17. Sorry to be going a little bit faster, but you can always stop and replay this. The algebra should be old news. 16. Outside is 8 times the whole thing is x plus 8, right? So 8 times x plus 8 equals the outside, 7, times, not 17. What's the whole thing? 17 plus 7 is 24. So 7 times 24. Alright, so let's distribute. 8 times x is 8x. 8 times 8 is 64. And what is 7 times 24? 168. We get rid of the loner, minus 64. 104. Divide by 8. 13. Great. Alright. The satellite moves in nearly circular orbit around the Earth. The radius of the orbit is 42,000. At 1 p.m. the satellite is at point A. At 5 p.m. the satellite is at point B. Approximately how many kilometers does the satellite travel? Arc length. Okay? So, where would I find that? Let's take a look at our formula chart. We're looking for arc length. Gotta go up a little bit. Arc length is, now, usually you see it as the other way around. Okay? So, the way we learned it, this was right here, but it doesn't matter where it is. It could be here, it could be there. Same formula. So 2 pi r theta over 360. Let's do that. So what's the radius? It told us in the problem. So 2 times pi times 42,000. Parentheses, and in theta over 360, I see theta over here is 60 over 360. So 2 pi 42,000, 2 times pi times 42,000 times 60 divided by 360. Right? And we hit enter. 43,982.3. Alright. That would be what? Kilometers. Not squared because it's not area. The designated fishing area of a circular pond is marked off with 2 ropes attached to a buoy at the center of the pond. Each rope is 9 yards long, so you see that in the picture. Together they form an angle of 170. So you could just look at the picture if you wanted to. Since we're finding the area of a sector, we go to our formula chart, and we're going to use the area of a sector, right? Pi r squared, theta over 360. So I'm doing pi 9 squared, 170 over 360. So let's do that. And we get 120.17. And this is going to be yards squared, because we're talking about area of a sector. Okay? Cool. Next one. So, ultimately, what is the approximate length of the arc? Length of the arc means arc length, okay, of the section labeled rent. Okay? So remember, that's 2 pi r theta over 360. Do I know r? Okay. If the diameter is 14, then the radius is 7, right? The diameter is 14, the radius is half, it's 7. Theta, well, what would the rent be if this is 90 and that's 126? So let's add up 90 plus 126 and get 216. And the whole circle is 360. 360 minus 216. Okay, gives me 144. Alright, so I'm going to do 2 pi 7 and then 144 over 360. Everything's being multiplied. 2 pi 7, 144 over 360. 17.59. And my units are centimeters. Okay. You might remember this one. Okay, the area of the following segment. So the area of a sector is pi r squared theta over 360. So that's going to be pi 9 squared 90 over 360. $63.62. And in the area of a triangle, base times height over 2. The base is 9, and the height is also 9, because they're both radii. 9 times 9 over 2. Okay, 9 times 9 is 81. Divided by 2 is 40.5 centimeters. If you type it in your calculator, you'll get that. 81 divided by 2, control enter. Okay, and our last step is we are subtracting 63.62 minus 40.5. We get, okay, 23.12 centimeters. Alright? And these are all actually centimeters squared because we're talking about area. Okay? Alright. So, and if you remember, this formula is on your formula chart. This is old news. It's on your regular formula chart. Okay, look at 22 and 23. So for 22 and 23, we're writing an equation. So let's remember our equation. I'll write it over here. X minus h squared plus y minus k squared equals r squared. It's on your formula chart, right? Equation of a circle, right there. You got to know that. H and K is the center, R is the radius. It's all on your formula chart right there. So, let's take a look. If the center is negative 1, 7, remember H and K are opposites because they're insiders. Insiders lie. It's always opposite. So when I put this in, I'm going to put X. And what's the opposite of negative 1? Positive 1 squared plus y. And the opposite of positive 7? Negative 7 squared. And then my radius is 5, so 5 squared. Right? So I rewrite this. And 5 squared is 25. Okay? Let's do it again down here. I'm not going to rewrite the original equation. I'll just use the formula it gives us. So the equation is x, opposite of 3 is minus 3 squared, plus y, opposite of negative 8 is plus 8. And that equals 8 squared. So I rewrite it. Don't forget the squared. That's 64. Alright. Last one. Can you graph this stuff? I'm sure you can. So the center is the opposite of h and k, or the opposite of these, which are 2, 3. Both positive, because in the equation they're both negative. And what's the square root of 16? 4. Okay, so the radius equals 4. So at 2, 3, I put a point. I'm going to go 4 up, 4 to the right, 4 down, 4 to the left, and just, you can make a rough sketch of a circle, okay? Doesn't need to look pretty like that, which is not. You just need to make sure I see points that make sense. So the center of this is the opposite. So -4, +1, right? Opposite of those. And the square root of 9 is 3. So r equals 3. So -4, 1, up 3, right 3, down 3, left 3. And I make my beautiful circle as much as I can. And that's your review. So you definitely want to be able to do all those things, and everything you need to know is on that formula chart. So definitely use it, okay?